That should begin to pop out on YouTube. And as always, if I could just get, somebody to confirm on YouTube that we're streaming out there okay, I really appreciate that. And then secondarily, it looks to me like we're streaming. And secondarily, if we can hear the student voices coming through on YouTube, would be fantastical. It's a delay like 20 seconds or something crazy. Okay. Then, and if somebody could go ahead and grab that link and just drop it into the comments right now, then later on when someone's like, I can't find the video, then it can already just be there because we're so cool. Because we're amping up our coolness factor regularly. Okay, and I'm sharing my video here in a sec. And then, let's see. No! Okay, let me try something. You do have my... Still dead? Okay, I'm gonna try a different thing right now. What did we normally do? What do we do? Man, I tell you, I hate this. Output. Input. Well, the alternative is it's nice when your audio pops out, And input device is a microphone, output device. We shouldn't have messed with it. Yeah. Oh my gosh. Yeah. Krapski. Let's see here. Okay. What do we normally do? Multi-output device. Preferences. Audio capture. Output. Nah, it's got to be the multi-output device. Okay. Well, I think that we can't be piddling around further, so I think we should just rock and roll without your audio pumping through, and I'll try to repeat it. And then, okay, so if anybody is like streaming gamer, any of those sorts of OBS experience, and you want to hang out right after class, we got a window. I'm kind of hanging out in the testing lobby to answer questions and stuff, right? Just, stick around right after, and we'll see if we can't debug this thing and get it finally cooked. So, but you can hear me okay, and that's the important thing, isn't it? Let's see. I just wanted to ask you, I hope maybe just, I don't know, you can either drop a comment or whatever. There we go. But, and let me just get the text channel up. There we go. Okay. I just want to say, with all the, just everything continuing kind of COVID and quarantine, I had this experience last night. I was just cranking on work stuff, and my son, who's in med school, texted me, and he's a BYU grad, and he was like, "Are you watching this?" And I had totally forgotten that there was college football, like, at all, right? And I know, not everybody cares about college football. I get it. And I'm not. Anyway, I've faded a little bit over the years, but in terms of my my loyalty to the sport, but it was kind of cool, right? And I do have a couple degrees from BYU and was on faculty, and so it was interesting though when the game was on. I don't know if any of you have had this experience. but I didn't realize how sort of like desperately lonely and isolated I had sort of become until I just glanced at my big monitor here that you can see, and like there was just college football and Curb Street, calling the game on ESPN. BYU did destroy Navy. But you know what I mean? I just looked over and there was just like college football. And for just like a second, it was like I was teleported back. Uh, Crap, how long has it been really? It's half a year? When was spring break? That was March, right? What's that, 6 months? Yeah. So we've just been in this kind of crazy lockdown mode, for about 6 months. And I guess I didn't realize how starved for normal rhythms of life I had actually become. So I guess what I'm really saying is I'm confident that all of you, most of you, are having comparable experiences. Yeah, is that true? Am I? You know what I'm trying to say? You're coping, you're kind of grinding through, but really life feels kind of on hold. You know, anybody with me on this? And for just that moment, it was almost like emotional, not just because I got to see BYU football, but um, in fact, I'm wearing today because it's cold. It's the weather's cold here, and so my AC's still turned on. So I actually have my. This is my Oregon State football sweatshirt because it's just colder in the house. But one of my three universities that I attended, Iowa, BYU, Oregon State. Anyway, I just wanted to say, man, just be aware, be like gentle with yourselves in the middle of all this stupid pandemic bullcrap. You just don't realize how hard it actually is on you. Maybe you do, maybe you really do, but often we don't. We're just kind of like plugging away, and we're like, why do I feel, you know, you know what I mean? This is just group therapy, okay? This will not be on any module exams, but I just want you to know that I think about you guys and you're trying to be college students and trying to pound and do the thing, and it's just freaking hell, to have that thing. So that's part of the reason that I'm available all the time on Discord. You know what I mean? If you want to check in, that's why I have the School of Rock channel. You know what I mean? That I posted an invite to that. It's just about trying to establish a little bit more in the way of social contact and kind of just humanity, human availability, you know? Anyway, and then frankly, just all the rest of the crap, outside of COVID, of 2020, right? It's just like, what the hell? Who came up with 2020, man? We got to reboot this thing, see if that'll fix it. Just power down and power back up. Maybe we'll be better. And that's actually, by the way, why I went with the scrolls with hats, or the whatever these guys are, little furry woodland creatures. My cartoon of the day. It just feels like a gentle, you know what I mean? It just feels like a gentle comic for the day, a little less, in light of everything. You know what I mean? That one just weirdly just made me super happy. Okay, so I just want to say, as you're going through all that crap, just make sure that you're trying to figure out ways to be just gentle with yourself, nurturing, emotionally nurturing. I know we're CS types, and we don't do much of that emotional nurturing. And some of you that are like heavy gamers, like you're like, what does everyone keep talking about? What a bad year it's been, and you're just like grateful no one's bothered you this year. That's been fantastic. But for the rest, it's hard. It's really, really hard. And I just want to say, look, we're kind of all going through that together. And I am actually on my phone because I'm looking something up that I want to play you. And my stupid solution, by the way, is I'm going to actually just play you a video like this, believe it or not, and hope that we can make this thing work. It's super low tech. I get it. Oh, hang on a second. That's not it. Could anybody hear that just then when I was doing that thing? I'm gonna dangle the whatever we call this thing. Okay.
You're not making any sense. Sorry,
Okay, hang on a second. So we talked about algorithms, and I was talking to one of the students, and we were talking about algorithms, and it's a question that shows up on the first module exam, and it's a concept I really want you to understand. And I didn't realize, well, I kind of realized, but let me just say I more thoroughly realized that for some of you there was still confusion about what it means, right? And so I came across, I remembered that I had come across this video. This guy's YouTube channel is called Josh Darn It, which is clever. And he does this exact challenge, the exact instructions challenge with his kids. I don't know if he's homeschooling or helping them, whatever. But he's trying to get the kids to give him written instructions for how to make a peanut butter and jelly sandwich. Have any of you seen this? Your life is about to get more complete, okay?
You're not making any sense. Sorry, you ruined it on purpose.
You know what? I'm hungry. I could really go for a peanut butter and jelly sandwich. Do you guys think you can write down some instructions and teach me how to make a peanut butter and jelly sandwich?
Yeah. I'm done.
Oh, yes.
Step 1.
I can also do it like this.
Get 2 pieces of bread out.
How's that?
Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it says. It says take 1 piece of bread, spread it around with the butter knife.
Get that closer.
Hold on.
Get some jelly, rub it on the other half of the bread.
No, Dad, open the jelly.
It doesn't say to do that. Put the bread
Can't hear it at all?
on top of each other. Take a big bite.
Oh, hang on. Is audio still dead? Okay, gotcha.
Let's just taste like a peanut butter and jelly sandwich.
How's that?
Sorry.
Is that volume okay?
I had to make it extremely specific.
Oh, good. I'm starving. Take 2 pieces of white bread out of the bag. Take the lid off the jar.
Oh, you know what? Actually, yeah. I think. Hold tight. I just realized. I think there is something. Hang on a second. There's a thing for like automatically determine input sensitivity. And I think that's causing it to do like gain control. I don't know, man. Okay. Let's try this again. And the cool thing is, it's not hurting anything, frankly. The continuity is not as important as sort of just the example of what this is trying to say. Are you perceiving why I'm showing you this relating to algorithms?
And stick it inside of the peanut butter jar. With the knife, scoop a bit of peanut butter out.
That means like a lot.
A bit means a lot?
In my world.
Alright. There we go.
Doing better than before, though.
Open the jelly jar. Squeeze it onto the other piece of bread.
No.
Done. Closer. Get 2 pieces of bread. Get some peanut butter. Take the peanut butter knife. Open the peanut butter. Put the knife in the PB. Get some jelly. Open the jelly. Squirt the jelly onto the bread. Take the butter knife with the peanut butter on it. Wipe it all over the piece of bread that's blank. Take the butter knife. Rub the jelly all over.
Okay. So I think you get the idea, right? By the way, how's that sound now? Are we okay on audio? Okay, all right. Thanks. Thanks for your patience. Again, this is pretty low tech. I get. I mean, high tech, low tech. Point just being, right, that this is an exercise in algorithms, right? One of the questions is, can you use English language with all of its ambiguity, right? And you notice all the problems. What the dad was doing was every time the kids gave him a description that had built into it an inherent ambiguity, he would just take whichever one was the most obnoxious, you know, because as long, you know, you can't say, well, hey, I don't know how to interpret that, or there's room for error. He's just going to demonstrate it by just, you know, take the bread, take the knife, you know, spread it around. You don't say what it is, you know. So the other one, I was debating whether I should even, I don't know if I should show this one because I don't want to get like a blocking message on YouTube or a takedown or something. But I was also reminded of Brian Regan, who had his famous, maybe somebody can just find it. I don't know what, and post the link. But Brian Regan was on, it might have been Conan. I can't remember. No, it wasn't Conan. It was actually a performance that they did, one of his albums, actually. I'll recognize it when I see it. But in any case, Brian Regan is talking about the fact that Pop-Tarts have instructions on the side. Has anyone seen this? You know what I'm talking about? And he's talking about how there's like more than one sentence. You know, it should just have, yeah, just toast it. You know, no, that's not it. You know, it's like take pastry out of pouch, and then it's like all these steps, right? And then one of them is it's like, you know, like who are these people that need to read the instructions on the Pop-Tart, right? And then it's like, you know, insert pastry into toaster vertically, and then he's like, you know, you got somebody who's got to read the instructions on the Pop-Tarts, and now you're going to throw the vertical concept at them, you know? So it's a very funny bit. It's not that long. If somebody can find the link and post it, that would be great. And same thing with, this one is called in Exact Instructions Challenge. If you guys want to post that. Is that the one? Because the thing is, there's different versions of the Brian Regan. Actually, let me see. Who was it I was talking to? I have a version of it that I like the most because I've seen different versions. Who was I talking to? You know who you are if you're here. Might have been somebody who was at a different time. Man, I'm just a mess today on the tech support side. I need a tech support person. Oh man. We'll get it. Yeah. Oh, good. Okay. Anyway, there's a. Hang on just a second. I gotta just do this because it's gonna make me crazy otherwise. Because I know which one. This is the one. It's at the Improv. Okay, here we go. I mean, you can watch them both, but I'm just saying this is Dr. K's, yeah, it's not the same one. That's my favorite version, okay, of that Brian Regan at the Improv, and you know, and again, for the people who are watching, you know, that can't be here right at this time, that are watching afterwards, just go to the chat, you know, just go to the Discord chat, and then I'm posting the other video with the Exact Instructions Challenge. Okay? So those are all there. Okay. Are you ready for bits and lectures and stuff? So ready. We are over ready. Let's get on to it. Let us stop piddling around. What is that called? Module 2? Chapter 2. And by the way, can I just apologize for the whole chapters and modules? It's like only so slightly off, and it's not really smooth, and I don't like it, but it kind of works, and I'm not entirely happy, and I do in fact have only myself to blame. Let's be clear about that. I can't pin that on anybody else. Okay, my friends, are you ready? Let's do this thing. So this is, hi, I'm Professor Charles Knudsen with a message for you about bits and data types. Okay. I don't know. It just feels like we're being hasty. We should linger for a while. Okay. So we talked a little bit about this already, so briefly about it. But to do this thing, to make these bits, we have to have zeros and ones. Ta-da! That's the foundation. And the truth is, you could kind of build such a system out of anything, right? Stick, no stick, lights on, lights off, wax on, wax off. I don't know. There's a new Karate Kid movie. Feels like that's not a bad reference. Little shout out to Mr. Miyagi. You could do it with fingers, 10 bits. And then they're like, you got to be careful because some of these become obscene gestures depending upon, culture, country. Exactly. That's right. Some of these are, there's one that's universal, but you know what I'm saying? So you could do with that's on, off, on, It doesn't really matter, but we'd like to make a machine out of it, right? We'd like to be able to really build stuff out of it. So if we want to build an electronic system, we're like, what do we do? And we can kind of go like voltage, no voltage, right? That's not too bad, which is actually remarkably like light on, light off, right? I don't know if this is going to be like, that's not really, can you kind of see it? That's the worst demo ever. Hang on. Just a second. I actually just happen to have sitting near me a box of crap. We could do it this way for the fire hazard. That's 1, that's 0, that's 1. How hot is that? That's okay. But no, there we go. Now we're talking. I probably have a better flashlight, but I just remembered that I had this just box of crap just sitting because I was looking for something. Yeah, so basically that's really it. 1, 0, 1, 0, etc. We got to go right there. There we go. And believe it or not, that's actually the building blocks. And by the way, what's cool about this particular flashlight is it actually has rechargeable batteries, and it has you can get into this if you want to dig the physics, but it has a loop there and a magnet that you can shake, and it goes back and forth through it, induces current and recharges the batteries. And so you can go like that to charge the thing up and then have battery. I don't know even why I have this. Probably because it's cool. I also don't know why I have this. It's more cool. Okay. So, let me see. I just saw the comment about starting that's rough. That's rough. Starting the California fires, trying to teach binary. That would be bad. Okay, let's keep going. You're like, please. So, here's the interesting thing. Trying to answer the question of, here, let me turn that back on. Trying to answer the question of when the voltage is on, right? When I've got a 1 versus when I don't is an interesting question. Because the voltage in the wire, I'll give you just an example here. This is just a graph. I just found this, somebody that's just doing measurement of the power coming out of your wall socket out of a 220. socket, right? It's not just like 220 volts right there. It's moving because physics, right? But mostly it's, staying above 220 volts. When you go below it, that's when you get like brownouts and, lights are kind of dimming and right because the power is actually dropped in the power coming into your house, things like that, right? But so just understand that voltage in a wire is not a discrete function. Remember discrete and analog? The reason why we talked about that. The actual voltage physically in the wire is not discrete. It moves around, okay? We have to just create a threshold and build circuitry. We're not building that circuitry, but the electrical engineers, bless their hearts, build that circuitry for us. And if you dig that, you might want to be thinking about electrical engineering. I don't dig that, so I'm not thinking about being an electrical engineer. But somebody has to build the little circuit so that when you're above a certain threshold, pick whatever it is, 5 volts, 2 volts, there's some standard, voltages that they tend to gravitate toward. But when you get above that threshold, the circuitry turns that into a 1, and when you're below the threshold, the circuitry turns that into a 0. So you see we talked about discretizing, which is like discrete, drop the E and tack on izing, right? Discretizing, to take something that's continuous and block it out and go, okay, you're a 1, you're a 0, you're a 1, you're a 0, you're a 0. Okay? That's what we're doing. So, for example, if you strap on an oscilloscope onto circuitry, and try to see a signal. Here comes a 1, here comes a 0. This is actually what it looks like, depending, right, on the system. A lot of times it's cleaner than this. Depends on exactly what you're looking at. And by the way, if you get into a mode where you're trying to say something and I'm not responding, then text, chat me, let me know if you're trying to say things that I'm not hearing. Okay, otherwise I'm going to keep going. Okay, so yeah, so you can kind of look at that with the naked eye and kind of go, yeah. That's right. Yeah, if the voltage is not going from 1 to 0, or even from like 5 volts to 0, there's some threshold. When it drops below that threshold, we call that a 0. And when you're above that threshold, we call that a 1. Cool, right? And the cool thing is I can strap like a clock onto that, so it'll like generate a pulse on some regular thing. That pulse can then be fed through circuitry into another thing to cause it to sort of move and to do things, because it's got a regular thing. And we'll get into kind of how all that works. But this is kind of what we do, And we kind of go, that's a 1, that's a 0, from the perspective of our binary. The actual voltage could be anything. And in fact, there was experimentation with things like, I don't really know if people like commonly do this today, but definitely was experimentation with, like, instead of 2 levels, what if there were 4 levels? You know what I mean? Like really hot, medium, mild, and 0, So I could encode basically, 4 values instead of 2 in every single pulse. So I could vary the height, like playing a trombone. Exactly. We want others to suffer as we have. That is what we're in this for. So, but you get the idea, right? We're discretizing it. So conceptually, it's the red line. Clean, 1, clean, 0, instantaneous drop. It's not instantaneous. And it's not clean, okay? So that's the foundation. That's the basic of everything. So binary is, bits are short for binary digits, okay? That is why they're called bits, binary digits. What are digits? So decimal digits. Any Latin-based language speakers here? like to enlighten us about how to say finger in your, what's that? No, English is... So I'm talking really about what we commonly call Romance languages. French, Italian, Spanish, Portuguese, and Romanian, exactly. Romanian never gets proper credit for it. But I mean, of all the languages, Romance languages, Romanian, Roman, Romania, no love for Romania. Because, I don't know, why? Because you dropped all that Slavic stuff in there, I suppose. I don't know. But anybody? Italian, French, Spanish, Portuguese? Let's go, French. French guy. What's our word for French? For finger in French? Doigt. D-O-I-G-T. Thank you, French, for making all spelling in your language absurd. Doigt. But if you actually didn't know how to pronounce French and you just looked at that, you'd go, doigit. You would almost say digit just by reading it, right? What about Spanish? Yeah, dedo, right? And in Portuguese, same. Probably with a different pronunciation. Anybody Portuguese speakers? Can I do my imitation, my Portuguese impersonation? No, it's really, really simple. João, obrigado. That's all of my Portuguese right there. And I have pretty much anything you ever need to know. Put marbles in your mouth, get drunk, speak Spanish. Boom, Portuguese. It's not that hard. That's right. Italian, so dito. Man, I think I'm missing a T on my dito. Anyway, but it all comes out of digit. It's the same. These are all cognates, and they come from digits. They relate to this word in English that we have, which is digits. We get a ton of our vocabulary from French, so 10 digits, fingers, 10 fingers, 10 digits, base 10. Boom. And that gives us base 10 math. So that's kind of where we start. So we already knew this. We do this kind of, instinctively by now, right? Every place holds values from 0 to 9. Now, this is one of the sneaky parts because, in every given place in a decimal number, there are 10 values. But there's no 10. There's no number character called 10, right? Goofy, right? 10 is 1, 0. There's no 10. It goes 0 to 9. So you just got to kind of keep that in mind. When we go base 8, what are the numbers? What are the digits in base 8? Anybody? Bueller? Any guesses? 0 to 7. How about base 16? 0 to 15, which we call F, but yeah. And then what about binary? Base 2. 0 to 1. It's just, that's the consistent pattern. If that helps, that's the consistent pattern. And I'm repeating this, even though you kind of know this. I'm breaking it out because we're gonna do the analogy with binary. Okay, this basically is always the ones. That's the tens. That literally tells you how many ones you have, how many tens you have. Like if this was money, right? How many $1 bills? How many $10 bills? $100 bills? $1,000 bills? $10,000 bills? I think we have all of those, right, in American currency. I think we do. I mean, I don't have a lot of experience left of the comma, but I think they exist, right? And then literally you can just kind of go, well, I got 4 10,000s. Okay, that's 40,000. I got five 1,000s. That's 5,000. When I'm done, I got 45,289, which is redundant because we're thinking in the same system. When we get to other systems, it'll kind of begin to help a little bit, like binary. So every value can hold a 0 or a 1, right? Because when you count, and again, some of this is repeat from like 1400, CS 1400, where you touched some of the stuff, but we're going to dive in a lot deeper here. So once again, you're going, let me back up. Right here, powers of 10, because it's base 10. What are the powers? Bueller? Yeah, if you're reading the slide, you're like, Dr. K, shut up, just keep moving. Powers of 2. So these are the ones, and these are the 2s. These are the 4s, the 8s, 16, and you're going to get really good by the time we're done here of just taking a number like 1 and doubling it, okay? 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. That, believe it or not, will get kind of like, kind of natural, you know? And then if you want to get crazy, you can kind of keep going, right? 2096 and a number that comes after that, that's double it. But that's the idea. So the real question when you're looking at binary, the way to interpret it is just to kind of go, okay, those are the ones. I got no 1s, I got a 2, I got a 4, no 8s, and I got a 16. And if you're anything like me, the first thing, I just remember when I came across this, you know, the first time, however old I was, and just being like, wait, does that really make all the numbers? Are we missing anything? You know, anyone have that reaction where you're like, wait, does that really make all the numbers? And the answer is, yeah, it really does, which is kind of strange, honestly, but it works. But that's the idea. And so when you take a binary number and you want to convert it to decimal, literally what I do, I just go to the right. I got no zeros. I got a 2, a 4, no 8s, and I got a 16. You can also start from the left, but the problem is you have to start by counting to the left and going, okay, that's 1, you know, that's 0th, 1, 2, 3, 4, 2 to the 4th, and then work your way to the right. But I think it's easier just to count starting from the right and going left, okay, when you're converting from binary to decimal. All right. And by the way, just stop me at any point, okay? Just that's part of why we have the live class and why I don't just drop a bunch of video podcasts on everybody, okay? So that you can stop and ask questions if there's anything confusing. And again, because we're all screwed up on the audio, I will repeat the questions for the YouTube folks. Okay, but yeah, definitely stop. Okay, what about this one? Largest value you can store in 8 bits. Just noodle for a second. Think about the intuition on that, right? If I took any one of these bits and I made it a 0, you know, the value of the thing would have to go down, right? Because it's like, well, let's go back again. I got 1, 2s, 4s, 8, 16, 32, 64, 128, right? I got one of each. I've only got 8 bits. I literally can't change any of these numbers without making the number get smaller. Everyone's cool with that, right? You ought to be. If you're not, see me after class, where you're going to help me debug my OBS problems. So yeah, right. That's it. So that's the largest value you can store in 8 bits. Okay. It's if you add it up, right? 128 plus 64, etc. That's 255. Okay. The next little part here is trying to just get you to wrap your head a little bit around some of how the numbers work with relation to the number of bits you've got. Okay, and that's kind of where we're going with this thing. So we just talked about that's the largest value you can store is 255, right? How many values can you store in those same 8 bits? Bueller. We have a vote for 256. Do we have a second? Do we have a confirm or deny? We got a little bit of seconding going on 256. I'm not going to argue with 256. The intuition's exactly the same as if I've got, if I've got a single bit and I'm in binary, right? What's the largest value I can have there? 1. How many values are there? 2, right? If I did decimal, And I said, what's the largest value you can have in a single digit of a decimal number? It's 9, right? How many values are there? 10. And the intuition is actually pretty simple. 0. Yeah, I got digits that go 1, 2, 3, 1 through 9, but that's only 9 of them. There's actually 0 to start. That's it. So the maximum value is all the bits turn on. The number of values is that plus 1 because you've got 0, which is when all the bits are off. Okay? Cool? Oh, yeah. So that's kind of, and by the way, all these slides are on Canvas. So if you just want to pull the slides down and just kind of walk through and remind yourself, videos are on YouTube, but the slides are on Canvas. Okay. Now, so what's the range, what's the range of values you can store in 8 bits? And the answer is it depends. And we're going to talk about 3 different notations that they're actually common. Unsigned is extremely common. 2's complement is extremely common. Signed magnitude does exist. A little less common, in my view. I could be wrong on that. I haven't done the empirical data on that, but that's my sense. So we got to talk about notation, and we'll do it kind of just touch it here, and then we'll come back because we're going to break down what each of these notations means. Really kind of quickly. Unsigned assumes that everything is a non-negative number, right? There's no sign bit. There's no concept of a negative number, and it turns out that there's a lot of data types that are just fine with unsigned, right? Anybody got any examples that pop into your head? I mean, as little as you know already, there might be some ideas or some examples that may pop into your head. Or not. It might be a little early. It might be premature. When we get into things like representing characters, and you've got 8 bits to represent characters, there's nothing about, there's no notion of a negative number representing certain, like what's a capital A? There's some number that represents a capital A or a lowercase d or whatever, right? So there are just a number of situations where there's no real concept of a negative built in. We'll deal with that. With sign magnitude, you can go from negative 127 up to positive 127, and with 2's complement, negative 128 to 127. That's a little weird, and I know right now that probably is like, okay, why? But we're going to break it down. And the intuition will be, I think, really clear to you. Cool. So let me do a little interlude on the size of a byte. So if I just ask you how many bits are in a byte, you're just walking around on the planet, being a CS person, and someone just stops you on the street and goes, "Hey, buddy, can you spare a couple of bits?" And asks you how many bits are in a byte. What would you say? What would be your reflexive answer? What do you think? What do you guys think? So, yeah, I'm just curious. What? I'm just curious. Well, a byte is I think the reason it's called a byte is because bit was already about like biting things. You know what I mean? It was like clever, which is why they spelled it with a Y. It's just kind of nerd humor. I don't know what it is. But no, here's the thing, and the reason I just wanted to just see, what's in your mind on that. There's The truth is there's not a strictly right or wrong answer on that, because if you were to say, okay, I'm going to put a gun to your head and you got to come up with a number and you got to mostly be right, then the answer would be 8. Okay? But if you said, wait, do you mean strictly speaking, every byte in the world is 8 bits? I would go, well, you got me. No. Okay? The first assembly language I ever worked on, I'm going to do my old white. Look, when you're rocking the Santa beard, you can play the old man card. Okay? That's like a rule. That's a rule of life. And I'm going to just play it. So back in my day, in the early 80s, the first time I touched assembly language, that machine had 4-bit bytes. And they had what they called, again, let's get the nerd force very strong with this one. They had, sometimes you'll refer to portions of a byte, okay? And the vernacular changes, that's part of the difficulty. We'll sometimes talk about words. It's a little loose. But back then, they would refer to a half a byte as, you ready for this? I may have to punch the plaid monkey when I'm done with what I'm about. No, but you're on the right track. Yeah, partial credit for being on the right track. It's a nibble. It's a nibble. I can't do it. The monkey is just too nice. Besides, the monkey is my only friend. Yeah. So they had these 4-bit bytes with 2-bit nibbles. That was real, though. That was real. That was my first. Oh, and instead of using hexadecimal to make the binary easier to grapple with, we used octal. Crazy. Which is base 8. Yeah. That was my. So all I'm saying is, and you're like, yes, Dr. K, but you're older than dirt. You're older than Santa, pretty much. Yes, I am. So, but the truth is that I am confident somewhere on the planet, there are still processors that are 4-bit bytes, And then you get into, but once you get above that, typically 8's like your limit, okay? And I would say 99% for all of our purposes, a byte is 8 bits. The reason that I'm belaboring this, though, is that you have to understand that bytes being 8 bits, here's my impersonation of a byte, bytes being 8 bits, you have to be able to get into individual bits. Like, I care about what this bit says. It impacts some behavior. Or these 3 together mean something to me, or this half versus that half of the byte, okay? So the reason that I think it's an important interlude is, are you going to encounter non-8-bit bytes in your life? Probably not. But the concept is really, really important. And are you going to, even if you're doing high-level software, the likelihood that somewhere along the line you're going to need access to some bit pattern, just some bit or some set of bits, is actually not low at all. It's fairly high. Cool. That's the answer to that, okay? And that kind of is my it depends answer. And almost universally 8 bits today, so I do admit that. So let's talk about this for a second. Let's talk about the number 5. How many ways could you represent it? And this is just kind of, again, if you want to drop these in the chat, or if you want to say them out loud, just drop them in. I got 5 as a number on the chat. I got 101, which would be as a binary number. 101, there's a 4 and there's a 1, right? That's 5. Right, because what's 5 in base 10? It's 5. It's that, our traditional Arabic numeral 5. But what's it in base 8? The same. That's the realization, right? And what's it in base 16? The same. Yeah. That's hard to encode information. Right. That's right. You could literally have 5 objects. Well, yes, but no, but the set of 5 apples sitting on the table can still represent the number 5. You know what I mean? I mean, we might not use it that way all the time. There we go. Thank you, Tristan, for the 5 apples. Okay, yeah, somebody suggested base 4, which would be 1, 1 in base 4. Yes. Let's see. And Roman numeral, somebody said. The Spanish word cinco would do it. As long as we're talking about, every language with its word for 5, right? And by the way, Italian, French, cinq, super pretentious. Spanish, cinco, cool. Italian, cinque. Boom, style points. Thank you, Italy. Gesundheit. Wait, well, how do you say it? How do you say it in German? Fünf? Are you making that up? Okay. Well, I trust you. That works. Fünf. It sounds like the sound that 5 tacos makes when they hit the ground, or that big sub that Hulk Hogan is flexing. These are just epic comments. That is Andrew. What is that? I want to say that's Japanese. What is it? Chinese. Is that a Chinese character? Okay, it's a more simple. I mean, I'm out of my depth when I get to Asian languages, right? I mean, that's not the only place where I'm out of my depth, but that's one of them. Yeah, right. So we have the Chinese character 4, 5. We have the little image of 5. We have yeah. So I'm just saying, there's a lot of different ways, right, to represent the number 5. Let's hit a few of mine, shall we? Oh, high 5 with the puppy with the cute bow tie. My gosh, crap! You just overloaded my cuteness circuits. It's in the comments. For those watching later, go back in the comments and look for the cute little high-fiving puppy. Okay. Well, how about that one? Boom. Just seeing, what the overlap is here, right? How about that one? Nobody said that one, right? The famous 4 sticks and then the one that goes across. The 4. What do we call those? Tick marks. I don't know. The tally marks. Yeah, we call them tally marks. What about that one? The die. Anybody besides me really uncomfortable calling a single die a die when I think they should all be dice? I mean, if moose can be singular and plural, I think dice should also be. Die just feels like you're being overly rude in the middle of a game of craps. You are correct, sir. Maybe nobody's. I don't want to confront anybody's mortality. That's the bottom line. All of the above. Exactly right. We have just the English word 5. We kind of went down that road. Symbols and, things, that say 5. There was some of that, right, in the chat, right? And the famous Roman numeral, right? So you guys came up with about half. I mean, and the actual number of ways in which you can represent 5s is kind of limitless, right? There really is a bazillion ways to do it. So why would I do it like that? Why is this my choice for this class and frankly for this major and for this field of software, whatever you're doing in this field with software? Why? What say you? No, this is not. Yeah, I want actual answers. I want answers, dang it. Okay, yeah. Why though? Why? I agree, it's the simplest language of the computer. But why is this our thing? Yeah, it's binary. I mean, we're not really these are like characters in a PowerPoint presentation, right? But they represent wires, lines that have voltage. That the voltage is high, the voltage is low. And so I can build zeros and ones, and out of that, remarkably, I can build this. That's crazy to me. It's absolutely insane that really just starting with that you can build all the things. It's amazing. But that's where we're at. Yeah. There you go. It creates this really very simple mechanical building block. I mean, it's electrical, but you know what I mean when I say mechanical. I can build stuff out of this. It's moving parts, basically, which is kind of amazing. So yeah, if I can't actually build something with it and perform operations, then it's useless. Okay, that's bottom line. So what we're gonna deal with though is, and we kind of are talking really about data types, which we'll get to a little bit what we mean when we say data types. And let me just back up. You guys mostly cut your teeth on Python if you took 1400 and then rolled in here. And in Python, you do deal some with data types, but it's not it's not an explicitly typed language. You don't have to say, like you would in C or C++, here's my variable I and it's an integer. What's that? Yeah. And so what happens is that kind of a language drags you closer to the hardware. Languages like Python are much, much higher up above, and you're like, oh, what's that one thing? I don't know, val, it's just value. It's my result, and you don't have to think too much about it. But down at the low level, you do have to think about it, okay? And what we're really talking about are integer data types. And remember we had that whole discussion about analog and digital / discrete, and we talked about real numbers and continuous things, and then we talked about integers, right? And the integers were just the numbers that didn't have any fractions, no fraction parts. The counting numbers, 0, 1, 2, 3, negative 0, negative 0, negative 1, negative 2, negative 3, just counting numbers. Those are the integers. And it turns out that there are ways of representing, fractional chunks in computers, floating point in particular, which we'll talk about really, really briefly. It's a real thing that is a big thing where the math people and the EE people and, that you have to have like a floating point processor in your CPU and things like that. But where we're really going to focus our effort is in the integers, okay? And we're just not going to monkey around with too much with, real numbers, as we call them. When you get to things like C, C++, Python, whatever, there are real numbers. There are numbers with fractions. Down here, when we got to muck with the hardware, we're just keeping it simple, okay? So it is really an issue when you're programming, but it's just not something we're going to worry about. All right. So let's talk about unsigned integers. We talked oh so briefly. Okay. There's no sign. There's no plus minus. Right. So there's no negative numbers. And when you've got an unsigned integer, you just assume that everything's positive. Okay. So if I say, what are the possible unsigned integer values with 8 bits, that first one obviously is 0, right? What's the one on the right? Anybody? Everyone's whipping their calculators out. Yeah, it's 255. Now, one way to actually do that easier, do that faster, is you kind of go, okay, there's the 1s, 2s, 4s, 8, 16, 32, 64, 128. What would the next one be? 256. So if we added, we haven't really done addition yet, but if you added 1 to this, you'd get 1 and 1 is 0, carry the 1, 1 and 1 is 0, carry the 1, and it would ripple all the way until you had 1, and all those would be zeros. So you're just 1 lower than 256. That's one way to quickly do it. And that'll make a lot more sense a little later on as we get moving. But yeah, 255, okay? And so we can use all 8 bits for the magnitude, right? Which is just like the size of this thing. So from 0 to 255. Yeah. Agreed. I was actually just looking on my phone. I had it, and I don't. I mean, I've got everything. Crap, man. I've still got Flappy Bird on my phone, for crying out loud. I do have the original Flappy Bird still on my phone. Yeah, I'm not finding it, but yeah, agreed. As a way of just the game itself, to me, became really annoying over time. But it is an interesting way to get in the habit of just seeing those numbers. Totally agree. I like that reference. If somebody wants to like put a little link with with that information on it, I was hoping I could just like show you real quick, but I'm failing at that. Okay. Yeah, thanks for that. Okay, let me see. There we go. 2048 is the name of the game. Okay. Actually, I'm going to do... I need to shrink that a little bit so I can see the chat better. Okay. All right. All right, one more interlude. You ever wonder about the fact that when you walk around the world, nobody starts counting at 0 except for us? You ever notice that? Anybody? Is that just me? Us being computer types, Well, this is why. If you start with an empty byte, its value is 0. Yeah, we don't count age at 0. Do they? Yeah. If anybody's got, if there's somebody can look that up. Let's get some definitive. Yeah. Well, we do the same thing, right? Where we're like, in my 25th year, which is when you're 24. Well, we do the same thing with like, the 7th century. That was the 600s, right? That it kind of throws you. That one-off problem, right? But the bottom line is that CS types, we start a lot of things at 0, even though, but the other thing too is it depends on, like if we're counting people in the room, there's a concept of nobody in the room, which is 0. And when we start counting heads, we go 1, 2, 3. So, but just understand that there's a sort of a representational struggle. And we have more of a comfort zone. Again, we as people that study computer science. No, the question was about whether you were talking about age, right? About whether other countries count age starting at 0, not numbers, right? Yeah, specifically age. So go to work. Go to work, Google friends. Okay. Anyway, but that's why just a little bit of a self awareness exercise for the nerd folk like us, on why we sort of do the thing we do. Okay. So it turns out that negative numbers exist. Who knew? And that they're useful. So we've got to be able to represent negative numbers, right? And again, we're not getting into the fractions and floating point and other kinds of representations. We're just talking about integers still, okay? But we need them signed. We need to be able to go. It's a plus or a minus, right? Now, part of what throws you here is that in our numbering system, if you don't see any sign, you assume it's positive, right? And yeah, I'm not sure. I just saw the comment. The comments can be edited. I'm not sure if that's to me or to somebody else. Oh yeah, you're talking about somebody up. Yep. Oh yeah, sorry. You're referencing the fact that in Discord, after you make a chat post, unlike text messaging, same with Facebook, by the way, you can just go up and re-edit the thing instead of reposting the same correction. Sorry, I didn't know if that was something directed at me. All good, man. I'd rather have the comments rolling than to have it be, just more static. So if you're going to represent negative numbers, how are you going to do it, right? So we're going to talk about 3 ways, and we're running out of time. We got this. We started late. That's my fault. But we're going to talk in the class about 3 different ways of representing negative numbers in binary. And what I was starting to say is that with our kind of numbering system, numbers are positive unless indicated otherwise, and the way you indicate otherwise is within a negative, with a minus sign, right? How are you going to do that with bits, right? Anybody? I don't know. Did we already? We didn't. Well, we kind of hinted at it really strongly. But what would you do, if you were coming up with it yourself? Right? What are you going to do? What say you? Yeah, the question is, you got to be able to indicate whether a number is positive or negative. So one of the Tristan said, make one of the bits determine if it's negative or positive. Just have a bit. And cutting to the chase, that is the canonical answer. We call it a sign bit. You just say one of these bits is going to indicate whether it's on, if it's on or off, it'll tell you whether it's positive or negative. Now I'm going to go with, let me throw something else at you. Actually, I want to go, where is it? No, I thought I had a slide. I'm going to back up. Maybe there's a slide. It should be right here, but if it appears to not be so, I want to bring it. Okay, so I'm going to use a bit. Which bit should I use? I got 8 to choose from. I can pick any one of them, right? Which bit should I use? That's one question. I want to just discuss it for a second. Either via comments or voice. But I got 8 bits to choose from. One of them is going to be my sign bit. The others are going to be like magnitude. And the other question is, which one means what, right? Is a 1 a positive or a negative? Is a 0 in that sign bit location a positive or a negative? So I got one vote for maybe the first one or the last. I like that. Why would you not have it in the middle? You could. What's that? It really breaks it up, right? It'd be like, oh, how much was that? How much did you pay for that couch? And you're like, well, I paid what, like 7.5 negative 2, 0.39. It's just, it's goofy. It's disruptive. It is mentally, cognitively, weirdly disruptive. Turns out it's also a pain to build the circuitry like that. Like, why? You got to put it somewhere. Anywhere in the middle is going to be weirdly disruptive. Beginning and end, pros and cons. So I got a question vote for first. Now, also, when you say first bit, do you mean the leftmost bit or the rightmost bit? Right. So Andrew's comment was, we put the negative symbol to the left. Why not just keep that the same? Do the same thing, and that does, that does actually resonate quite a bit. And then we've got some debate about what was the actual term we used? Leftmost or rightmost? Oh, the first. What does first mean? And that actually depends. So that's ambiguous language. First, but leftmost and rightmost is pretty clear. Yeah. So these are good thoughts. I just want you to. The truth is, I'll bet somewhere in the early days, everything was tried at least once. Okay. We're running out of time here, so I'm gonna spoiler here. What we do is we take the leftmost bit. That's big spoiler number one. Okay. We take the leftmost bit, and that's the sign bit. Can you think of one thing that becomes super easy, or any advantages to having that leftmost bit be the sign bit? Advantage. Well, let's go with advantages first. Not everybody reads left to right. Not everybody reads left to right. Right? Arabic goes right to left. Hebrew goes right to left. It does buy you that, that the rightmost spot is the 0th position if you're going. And in fact, we do count these from right to left. When we go, that's the 0. That's the least order, the low order bit. It's worth the least, and it's 2 to the 0, right? Then it's 2 to the 1, 2 to the 2, 2 to the 3. Okay, so we do in fact kind of number them a little bit from right to left, and or we can think of it as low order to high order. Okay, where high order is on the left. But yeah, and then what about, real quick? Let's end on this one. What about up or down? You got to have. You got 1 and 0, and one's going to be the negative and one's going to be the positive. What do you think? You got 2 choices. There are only 2 choices. I'm waiting for votes. Down what, though? Yeah. No, that's right. No, to your credit. To your credit. Yeah, which one would you pick as negative? Let's just ask it more directly that way. Negative. The negative, when that bit says I'm negative, is that a 1 or a 0? What do you think? Well, spoiler here again. I'll give you the spoiler. And the answer is the way we do it. It's not like eternally right. You know what I mean? It's not like a natural law. This is CS, not physics, right? We're not bound by natural law for the most part. We make a bunch of crap up and then we just build stuff out of it, which is pretty cool. No, when the sign bit is on, that's negative, and when the sign bit is off, that's positive. That's just how we do it. There's nothing true about it, right or wrong, some great sense. But so here's the thing. You give me all zeros, what's that number? 0. You give me a number that's all zeros and then a 1 at the very end, what's that number? Positive 1, right? It's kind of what it looks like. And then at some point, I got to deal with negative numbers and have that bit. At the far right. Well, yeah. What's it? If it's on the far left, that depends. That depends on the notation. And then that's the teaser for next time, which is there's sign magnitude notation, one's complement, which we're going to talk about as like a historical reference point, and two's complement. Today, sign magnitude and two's complement persist as important and relevant chunks of computer systems. So it depends on the notation as to what that means. In sign magnitude, it would be -0. How about let's just leave you with that one to noodle on, okay? 1 and all zeros in sign magnitude is -0. Is that a good stopping point? We're out of time. We're over time. We're over time. Wow, we're really over time. I'm so sorry. I apologize. But let's, and then somebody's calling me. I don't even know why. Yeah, let's stop right here. And then, as I said before we got started, if anybody wants to stick around and help me debug the OBS madness for a little bit, no pressure on that. But if you'd like to do it and learn and figure out and help me, that'd be wonderful. That's what I'm going to do immediately after. And I'll be available. I think others might be. I think Zach is still in the chat. Yep. For, if you need help with homework stuff and questions about everything and whatever. Okay. So I'm going to go shut down YouTube and then I'll just stay on chat. You bet.